Good afternoon, class. Today we'll be talking about deductive reasoning. It's different than inductive reasoning. It's sort of the opposite way. For instance, inductive reasoning again, the last two videos have been where I was at my place being filmed. Now I'm back at the school. You might have been getting a conjecture already after the last two films that I was going to do the entire section at home. Well, I proved this conjecture false with this example. We are here at school for this video. But deductive reasoning, it uses facts, definitions, properties, and laws of logic to form a logical argument. So at this point, what we're trying to do is make a logical argument for why something is a certain way. Or we are trying to show that something is for sure true. Laws of logic, there's two of them, at least two that we're going over. The first one is called the law of detachment. This is not where we take off an arm or a leg or a nose or something of that like. It's where we already have a true conditional statement. So a true conditional statement might be, let's look at the one below. If the flip method proves to improve learning, then Mr. H will continue it for the whole year. That is a true conditional statement. If I was told something that is true, for instance, after the first test here, I noticed, hey, look, everyone's doing a whole lot better than last year. So it showed to me that it improved learning. Therefore, I would then continue it for the rest of the year. So if the conditional statement is true and the condition has been met, the conclusion will happen. An example of a false conditional statement would be something like, if Mr. H gets a haircut, then pigs can fly. For all those out there that want to come up with that, oh, what if a pig gets on a plane? Alright, yeah, I get that. That's not the meaning of this part of it. If Mr. H gets a haircut, then pigs can fly. If I get a haircut, I didn't see a whole bunch of pigs all of a sudden flying about. Nope, not a true statement. But if it was, then whenever I do get a haircut, then you should see pigs fly. The law of syllogism. I like to think of this as a domino where one causes the other. There's a very famous poem. I forget what it's called, but it's on this screen for you. For the want of a nail, the shoe was lost. So wanting a nail, they couldn't put on the shoe for a horse. Okay. And then for want of a shoe, the horse was lost. The horse didn't have a shoe, so therefore the horse wasn't able to be used. For the want of a horse, the rider was lost. The rider needs a horse to ride to give a message. Okay. So there is no rider. For want of a rider, the message is lost. If there's no rider, there's not going to be a message. For want of a message, the battle was lost. Sometimes a little bit of information, as simple as a little bit of a message, could be the difference between a won or a lost battle. And for want of a battle, the kingdom was lost. Yes, a battle could decide the fate of a kingdom. I could sum up all these statements. Instead of saying all of these, I could say, for the want of a nail, the kingdom was lost. Because the wanting of a nail caused a shoe to be lost, which caused the horse to be lost, which caused the rider to be lost, which caused the message to be lost, which caused the battle to be lost, and eventually the kingdom. So the want of a nail caused the kingdom to be lost. This is the law of syllogism. The way that we mathematically write it is this: if Q then R, and if R then S. If Q then S. So the first two, they are connected by R here. So if Q, then R. Q causes R, which in turn causes S. So I could just sum it up as if Q, then S. Alright, so let's just say another example of law of syllogism. Let's go this way. If Mr. H wears a purple and yellow striped hat, then he will look stylish. If Mr. H looks stylish, then important people would want to be associated with Mr. H. If important people want to be associated with Mr. H, then he will have important people visit him in his classroom. And if Mr. H has important people visiting him in his classroom, then you could expect to see an important person other than Mr. H should show up in the next day or so. Alright. So here we go. Purple and gold striped hat. So looking stylish. Now all I have to do is, according to that law of syllogism, if I wear this hat, then I will get visited by important people. So now all I have to do is wait for them. Oh, sweet. Oh. Yes. Oh, that's not interesting. Sad news. That unfortunately was not a true conditional statement somewhere in there. So even though the law of syllogism would let me say if I'm wearing this hat, important people such as governors and presidents would show up to visit me, was unfortunately not true. Yeah. Alright. So let's use the law of detachment in two other scenarios. If I want you to make a valid conclusion, these are two things that we could be doing. If two angles have the same measure, then they are congruent. Alright, that's a true conditional statement. If two angles have the same measure, then they are congruent. If I know then the measure of angle A is 90 degrees and the measure of angle B is 90 degrees, well, measure of angle A and measure of angle B have the same measure. So the valid conclusion is angle A and angle B are congruent. Or angle A is congruent to angle B. So if I was looking at something like this in example problem 1 here, right here, this is what they gave me, this would be my answer. Angle 1 is congruent to angle B. The if was met for a specific case, so I then do the then part for that specific case. Let's look at another one. Pythagoras takes the nap at 4 p.m. So if I put this in if-then form, it's if it is 4 p.m., then Pythagoras is taking a nap. So all of a sudden, it is 4 p.m. on Saturday. We have a specific case being met. Therefore, Pythagoras is taking a nap. So this is just a quick example of how we use the law of detachment, where we are given a true conditional statement, and then we're given something specific, and we apply it to that specific case. The condition's been met, so I conclude the conclusion. Now, the law of syllogism, this is the dominoes, so one causes the other, which causes another. So I need to make a valid conclusion. If two angles are both right angles, alright, so two angles being right angles, it causes them to have the same measure. Okay, if two angles have the same measure, then they are congruent. Okay, so right angle causes same measure. Two angles of the same measure cause them to be congruent. So the dominoes fall, it's if two angles are both right angles, then they are congruent. I got rid of this middle part here. And there we go. There's my conclusion, my answer. The next one. If Jesse get a job? Wow. If Jesse gets a job, then he can afford a car. So Jesse getting a job causes him to be able to afford a car. If Jesse can afford a car, then he buys a car. So again, the middle step here, or the middle domino, is the affording a car. So if Jesse gets a job, then he buys a car. And there we go. This is how I use the law of syllogism and the law of detachment. These are pretty straightforward. If you have questions, please ask. The only other thing I might ask you is how to tell the difference between the two. So for instance, determine whether each statement is the result of inductive or deductive reasoning, and I want you to explain why. So the first one, for the last 2 weeks, Mr. H has gone around helping students during the class period. That's true. You conclude that Mr. H will help students during the class period on Monday. Alright, so you've seen me helping students for 2 weeks. And then you make a statement that I should be helping students on Monday. Well, that looks like you looked at a pattern and you've made a statement about it. Unproven, but you still made a statement about the pattern. So it's inductive because you made a conjecture based on observations. The next thing that we might talk about is the rule at work is that you have to work the full week to get paid on Friday. Okay, so you have to work the full week to get paid on Friday. That's the rule. You were paid on Friday. Okay. So another fact, a rule, a fact, okay. Therefore, you went to all of your classes. And a conclusion based off of facts and rules, I'm pretty sure this is deductive because of what I've been given here and what I'm using. Yep, because you use rules and facts to make a conclusion. Well, at this point, you should know what the law of detachment and the law of syllogism is. You should know how to use them. You should also know what deductive reasoning is. It's kind of the reverse of inductive, where you use facts and properties and rules to form a logical argument. In the other case, you looked at a pattern and you made a statement that's maybe true. You should also be able to tell me the difference between the two at this point. Yeah. So, till next time.